Okay, so Jasmine is a test-driven development framework. They call it a BDD framework. BDD stands for Behavioral-Driven Development. Does anyone here practice TDD right now? In any form? Okay, so we've got a few. Anyone practice TDD in JavaScript? A few? Okay, what do you use? Are most of you on Jasmine or Mocha or Unit? Okay, cool. Well, this will probably all look a little bit familiar, at least to you folks. But I just want to show it to you. I'm going to talk a lot about the the theory behind this and the best practices and all that. But I want to jump right into just some code examples. I think if people see the code, it helps them visualize what I'm talking about when I talk more about the high-level stuff. So, a Jasmine test. Is this font size good?
Yeah.
Is that all right? You can all see that? I'm standing in front of the. Okay. So this is a text fixture, right? It's just an HTML file. You can see that I've got the Jasmine libraries included here. I have two JavaScript files. This one is the source file. This one is the test file, right? And at the bottom, this is just boilerplate code. I did not modify this at all. This is just what Jasmine gives us. So all I did is I downloaded this. This is straight from their GitHub, right? You just download the latest version. They give you this file, and all you have to do is reference it to your test file and your source file, right? So what I've got here, and you can see when I pull the bar. All right, what I've got here is a simple math class, right? I've got an add method and a subtract method. Couldn't be simpler. And the tests look like this, right? So it does basic algebra. So what we have here at the top, that describe function, it's calling the function describe, which is part of the Jasmine library, right? Does basic algebra. So that is the description for my suite. So usually a file has one suite, and a suite is a collection of specs, right? You can start a spec using this it function, right? I guess you can't, my comments are a little bit chopped off here. But this is what a Jasmine test looks like, right? So I've got this nice little description here. This is called an expectation down here. Other frameworks, if you like other languages, they're called assertions usually. So if you use whatever C# or Java, or that's my expectation. And then this over here is called a matcher, right? Which just well, does exactly. I probably don't have to describe that. Probably makes sense, right? So this is about as simple as it gets as a test. And what happens when I run that is it looks like, oh man, my bookmarks got chopped off. It's way over here somewhere. Sorry. Alright. So right there, this is what Jasmine gives me. Identify. There we go. Alright, can you see that? Is that too small?
Can you blow it up one notch?
Better?
Good. Yep.
Alright, cool. Alright, so what you can see here is that you saw that I passed descriptions to my suite and to my spec, and it basically generates a little bit of documentation when it runs the test. So Jasmine is a self-documenting unit testing framework, right? So that's really, really, really neat, because not only does it run your unit tests, it kind of generates living documentation that you know is accurate at the same time. Really cool, right? And this is 100% in JavaScript, right? It's 100% client-side. There's no server-side code here at all. That's just how it works. So that's a simple example. Go back to my slides here. So just to reiterate the terms. So we talked about that suite. That was at the top using the describe function, right? We had a spec, which is a test, right? The expectation or some other assertion, right, and the matcher that does the matching part. Those are the terms that we're talking about here. So, I wanted to, I've got notes here. I wanted to say, when I started doing this, when I started using Jasmine, right, we looked at all of the alternatives, and there really, it seemed like two main competitors to this. The first one is QUnit. QUnit comes out of the jQuery team. It's a little bit, when we kind of reviewed these QUnits, a little bit older. It's kind of like that first generation, you know what I mean? It wasn't quite as feature-rich as far as the documentation on things. It seems like Jasmine was sort of the step up, and then the other competitor would be Mocha. When I looked at it, what I liked about Jasmine is that Jasmine had all the assertion and the matching was built into Jasmine, whereas Mocha relied on 2 other libraries that you had to import. So Jasmine was a little more cleaner. Mocha had better syntax for doing asynchronous tests, testing asynchronous methods. But then Jasmine 2 just came out and it basically copied Mocha exactly. Right? So now Jasmine is the best of both worlds, right? They're actually, the 2 frameworks are like almost identical at this point. They kind of stole each other's features and they're basically almost the same. 2.0, right? As I said, it's 100%, Jasmine's 100% client-side, the basic test running framework, but it comes with some integration parts. The original version, it had, to hook into test framework and stuff, it was written in Ruby. There's a Ruby gem, right? And then the main change in 2.0 is that the server-side framework for that, they rewrote it in Node, right? So it's now 100% JavaScript on client and server side, right? But everything I'm showing you today is 100% client side. So TDD, whoops. TDD is test-driven development is a process, right? And it describes the process of developing code by writing unit tests first, right? And it's basically, it goes something like this. I am going to implement a feature, and I start thinking as simple as possible, what functions do I need? And I start with basically bottom up, right? What are the simplest nuts and bolts? And I write the test first, with several specs, right, or test cases. I write, 5 or 6 or however many specs I need to test that function. Then I press go and I watch the tests fail. That's an important step. Then I write the function. Then I press go again and I watch the tests hopefully pass, or at least some of them pass, and then I fix it and then I run it again, right? So a few important steps. The test comes first. Watch the test fail before you go and write the function. And just to get our terminology straight, right? Jasmine bills itself as a BDD framework, behavioral driven development. BDD though encompasses a lot more. It's a business process too. Requirements gathering and documenting. So BDD kind of encompasses TDD plus all the business analysis kind of going with it, right? So this talk is strictly about TDD, but I'm also, I'm not just going to show you Jasmine, I'm going to talk about some of the theory behind that too. So, and just to differentiate, TFD is test first development. That would be like how you test like a public-facing API, where you write the tests for dozens of functions first, right? And maybe a different person writing the tests than actually writing the functions. In TDD, which is what we're doing here, it's tests and then that function, tests and then that function, and it's for internal stuff, not public-facing APIs. So a good unit test, right? This is important. The crux of the matter is you only want to test small, well-defined pieces of code, which means you have to decompose your function into very, very simple pieces, right? The biggest mistake you can make is to try to test too much in one test, which sort of forces you into the pattern of keeping your function small, right? A single test should only call a single function. Now that becomes an issue when you start doing things like I've got a function A that calls B, which calls C. Well, you can't test function A without also testing B and C. So there are ways you work around that, and I'm going to show those to you. Right? Okay, so let's do, I picked another little example, and let's just, yeah, they say you're not supposed to live code in a presentation, but I'm going to break that rule and do it right now. Why the heck not? This is very, very simple, right? We're going to write a test for a function I wrote, or a function I'm going to write called disemvoweler, right? That just takes the vowels out of a string. Simple, right? So, all right, I already did this. I already wrote this, so I'm just going to delete it, right? And we're going to write it again. Whoa, don't love cheating. Alright.
Yeah, live coding, huh?
Yeah. So, all we're going to do is take the vowels out of the string. What do I need to test here? Someone give me a simple one. Like, what's the simplest possible one?
Null string.
Null string? Okay. I was waiting for that one at the end, but yes. Why the heck not? What are we going to do if it's null? We probably want to throw an exception, right? So, let's see. It throws an exception when given null. Very good. Function, whoops.
Null or the empty string?
Two different things, right? And we should probably test them both.
Absolutely.
Okay,
Right?
I thought I heard
Said
null.
null.
Okay.
So expect null, whoa, dot to throw string must be populated. Okay.
And you got a comma after your string at the bottom.
Comma after my string. Thank you. All right, very good. So what else?
You're not actually calling the method.
I'm not. Oh, you're right. My bad. Disembowel. Disembowel. Oh boy, I could not have picked a harder method to spell for this. All right, cool. So, well, what else? Well, we need to give it a string, and we need to take the vowels out, right? It removes, and we should probably differentiate between uppercase and lowercase, right? So, lowercase vowels. We're good. Expect disembowel. And we'll just say American Eagle or something like that. Not too equal, and that would be something like that. You know, we want to keep the space, right? Important that we test that. So this is a good test for more than one reason. Equal.
You got a D in there.
G. Oh yeah. There we go. All right. Well, I wanted to pass the first try, right? I want to impress you, so please correct me. Well, we probably want to test uppercase, right? So it removes uppercase vowels. Alright, do that so don't forget. Expect disembowel. There. Not to equal, and that's going to come out to, ooh, what do we do about y? I don't know. 50% of the time. I can't test that, right? Because it's not idempotent, right? I'm going to get a different result each time I run the test. Okay? THR. Okay. So, just for posterity, let's make sure we get them all. Removes all vowels. And that would look like. So let's just make sure we get them all. O-U dot to equal blank. And one more. Someone mentioned blank strings, right? What do we want to do with blank strings?
Return a blank string.
Return a blank string? Sounds good to me.
That removes no consonants.
Returns blank string, or returns blank string when given blank string. So, just like that. Okay, removes no consonants. Now, do we need to write a separate test for that?
That's the major case.
Yeah, but those.
Yeah.
Yeah.
We'll make you have to type that.
What's that?
I'll copy that one. We won't have to type that. Yeah, we should write that one.
Yes.
What about symbols and stuff?
We could do symbols. Just depends.
So in other words, non-Latin vowels.
Yeah, you can imagine that crashing a lesser library.
So is there a hidden assumption here that we're working with ASCII?
Well, all good things we would test if we were real serious about this, aren't we? So,
Are we?
I don't know how long you want to stay here tonight.
I guess we're not.
Tomorrow? Yeah.
Right, tomorrow, 8 a.m. Well, it's a little bit funny, right? The thing is, you can write a lot of tests really, really fast. So I have a feeling I like to do this because when I show people like a simple function, I've got like 40 test cases. They're like, wow, that's taking you all day. But I just cranked out like 5 in like, what, 2 minutes? So that looks pretty good, right? Who wants to give me the one-liner to pass the test? Someone?
Filter function?
What's that?
Filter function?
Filter function?
Slash AEIOU
Okay.
slash I.
How do I start it?
We have to first check.
What?
You have
It's
to
the
first check.
JavaScript meetup. Something to do with
If not string, you have to return string CR instead of throw an exception first.
Let's see what I have before. Pull up, I forgot exactly what it looked like. Ah, string replace. All right. Well, just pretend I just wrote this. All right. Cool. I'm disappointed, right? That no one just yelled that out.
So that one's missing several things already, though.
Well, that's the point, right? We watch the test.
Sorry.
Maybe we won't pass the first time. Okay. Removes all vowels from a string, throws an exception when giving no. Okay, so we failed the test. We forgot to throw an exception, right? All vowels from a
You
string.
had the wrong function there.
What?
You have an ER in your other file.
Disembowler. Oh, my bad. Why didn't somebody catch
That's why I
that?
kept auto suggesting it to you.
Nice. Halfway there.
Of no. All right, so caught that one. Expected hey there to equal hey there. Expected AEIOU to equal. All right, so I passed 3 and I failed 3, right? Y'all can see that. 6 specs, 3 failing. So I can click here. I can see the ones that passed and the ones that failed. Very cool. So what did I miss? I, right, for the miss sort of case, right? And equals no. Throw.
Shouldn't you also handle like all the other types if you're gonna handle that? Like handle like integers or.
Well, I mean, it depends. It depends on how deep you want to go. It depends how important the function is to you. So there's such a thing as going too much, right? I think some people get the idea that test-driven development, like you have to test every single possible case. And maybe if you're writing like medical software, that you do. But the truth is that you can't possibly do it all, right? So you do have to pick and choose a little bit. I'm always skeptical of anyone who goes too far to any extreme in programming. You know what I mean? It doesn't matter what they're talking about, normalization of databases, who knows, right? There's always too much if you go too far. So, and then let me copy this. So, just like that, and, all right. One failing. All right, so I got to wrap that in exception, but you get the point. I'm going to move on. So that's pretty trivial, but it shows the process and the way you have to think about this. And it is profound in that if you start thinking about writing code like that, you're forced to adapt a very bottom-up approach to writing code. I find myself, when I'm not test-driven development, doing this top-down kind of design where I'm like, all right, I'm going to do my class design first, and then I'm going to write the outer functions, and then go all the way out to the leaf functions. I force myself not to do that when I do test-driven development, because the first thing I have to think of when I'm doing TDD is, okay, what are the simplest functions I can test, and where can I start, given that I haven't written the code yet? So, while it's kind of self-policing, it actually works, and I recommend you try it, because it does make you a better coder, in my opinion. So, principles of a good unit test. Let's see. Did we satisfy the requirements? Well, it was only one piece, right? We had what, 6, 7 tests for one function. That sounds about right. The function wasn't doing too much. Okay, we did not have that A calling B calling C problem. That's supposed to say should test first. I missed a word there. But we tested it before we wrote the function. So very good. And then there's an important step I didn't mention in this process. The acronym people use, or not the acronym, but sort of the mantra people use, right, is red, green, refactor, right? So red, write a test that fails. You saw me do that? You know what? Oh no, I missed something important. After I wrote the tests, I should have run it before I wrote the function the first time. Right? I should have run it just to watch all 6 tests fail, so shame on me.
But it did all fail.
Yeah.
No, okay. Yeah, no. That was unintentional. Give me a break. Okay?
I meant to do that.
So, that's exactly what I meant to do. Right? But believe it or not, I've had times where I write 6 or 7 tests, and then I run it, and one of them passes when the function is blank. It has happened. It's usually some like null versus one, or JavaScript, which is equality. I'm going to talk about that in a second, but it does happen. So write the test, watch it fail, okay? But the refactor part is good too. If you can write your functions first, write all the simple functions before you compose them into classes. Then it makes it easier to do your class design after you have all the functions written. So that's why the refactor, the purple button here, is an important part of that, right? So red, green, refactor. And I'll show you, I'm not going to code this one on the fly, it's too complicated, but I'll show you one where I did exactly that and why I think that approach works best. So, do you guys, there are no girls here, are there? Jeez, alright. Do you guys know Conway's Game of Life? Yeah. Alright, so Conway's Game of Life is this cool little game where, oh, I saw this one. It's so you start with this grid, right? Can you all see this? It's a few little dots on the screen, and you hit run, and it creates all these crazy patterns based on a few simple rules. And the rules are, let's see, if it's a blank cell and exactly 3 cells surrounding it are not blank, then become alive. If it's a non-blank cell and 2 or 3 cells around it, 3 or 4, I've got it documented in my unit test, so we'll see if you're right about that. Yeah, so if it's 2 or 3 or 4, right, if you're alive and 2 or 3 around you are also alive, stay alive, otherwise go blank. So it's like 2 simple rules that generates all these complex patterns right here. And people have done like crazy amazing things, like done mathematics with these cells running around the screen. So it's like a cool example of complexity theory where like a few simple rules create crazy complicated behaviors. So you can see that one froze there. Let's clear it and try another one. Oh, the gossip glider gun, this one's cool. This is not my app, by the way, I just googled this. So there you got one that like shoots out little deals.
Gliders.
Right, gliders, yeah, shoots out gliders. Right? So this is a cool thing they teach like in computer science, but I made my own. Mine is not graphical. I didn't get around to like actually making a graphical version. Mine is just code, but let me show you what I did. So, again, I've got my test runner spec. All I added, I've got, in this case, I broke it up into two JavaScript files, 2 classes, right? And I did that after the refactor step of my test-driven development. I originally had it all in one big file, just tests. Then I refactored, then I made objects, right? So object-oriented JavaScript, 2 objects, okay? So the rest is all boilerplate down below. That's just what Jasmine gives you. All I had to do is include these 4 lines here and put the stuff in the correct folders, and Jasmine finds it. So rules engine, right? So I've got my test suite right here, and here's a little cool Jasmine feature. This is before each. What that does is runs code before every single test. So that's a good way. That's a cool little feature Jasmine gives you, where you can kind of do your exposition, where you can set up your set stuff up, right? I've got describe. Now I've nested them, right? I didn't do that in the previous ones. I've got describe nested with describe. So 2 nested suites, right? And then my specs. And all right, very simple. Resurrects a dead cell if surrounded by 3 live cells. Okay, so here's my engine class, the rules engine I wrote, and I call my private function in this case, very good. So I do the same for 4 live cells, for 2 live cells, right, 0 live cells. 0 is important, right? You always want to test like those. You always want to test the zeros and the nulls and stuff like that. I didn't do any error checking in this, so this is going to cause all kinds of mayhem if you try to throw nulls in here and stuff like that. But always test the zeros. So here's for if a cell is already live, here are the rules, right? If it's surrounded by 2 live cells, you want to, this function is going to return true, right? So is living cell alive next period basically says you pass it a number, the number of surrounding cells that are alive, and it returns whether it should be true or false on the next round, right? So I write my tests, test out a few numbers. I don't test them all, right? I could have done 0, 1, 2, 3, 4, 5, 6, 7, 8. I don't know, it's overkill, right? There's always like, there's such a thing as overdoing it in TDD. So here, this is the function that calls those ones I'm just testing. Or, well, no it doesn't. This is another function, get none surrounding cells alive. So we're going to pass in the matrix, which is the whole board, right? This X and Y here is the cell that we're going to test. right? And so this represents the whole matrix, the whole board. In this case, it's just a 3x3 board. This is the cell we're testing, cell 1, 1. So in this case, cell 1, 1, which is the middle cell, which is this one, it's going to be, counts, right? It counts. So surrounding that would be 0 cells, right? And then I just go on down the line, yoink, 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 right? Test out a few of these cases. So in this case, cell 1, 1, which is this middle, is surrounded by 1, 2, 3, 4 live cells, right? So I expect this function to return 4. Simple, simple, simple. So I fill out my tests. Now, this is where it got complicated. As Conway's game of life works best if you let things go off the edge and appear back on the other side, right? Kind of like Pac-Man. So the complexity kind of goes up a notch when I start testing this. But really, as you see, these tests aren't that complicated, right? So my function just went to being like a really simple one to just a kind of simple one. But I test all this stuff too. And this basically tests the stuff that goes off the end of the board, or basically that cells on the left edge, pick up the count from the right edge, and cells at the top pick up the count from the bottom and the corners and all that kind of stuff, right? So, those are my two basic functions, right? The simplest ones. Given the number of cells that are live cells that surround my cell, should I be alive, and do that actual count based on the matrix that I cast in. Now we get to something a little more, just a little more complex, right, as far as testing. So let me show you those. Let me show you those two functions first, right? Because normally I would have written these tests and then the function, written the test and the function. So let me show you the functions. All right. Well, here's is living cell alive next period. What could be simpler than that? You pass in the number of surrounding alive. If it's 2 or 3, return true. Otherwise, return false. Right? You were wrong. Didn't you say 3 or 4?
Yeah, I was wrong.
Yeah. Okay.
I got the book on the car.
Okay. And then is dead cell alive next period? Very simple. Return true if it's 3. So the tests are actually a lot more verbose than the code. But I think that's a good point. A lot of people would throw this in line with other functions. I would always break something out like this into its own function. As simple as it is, it's its own piece of functionality, right? Be good developers and decompose everything into as small functions possible, right? This logically makes sense. So let's run it and see if it worked. All right, so these all passed. Very good. You can see that my tests for wrapping around the bottom edge, the top edge, the corner, those all passed, right? The next one gets a little more complicated because we get a dependency problem, right? In this case, I'm going to show you the actual function I wrote first, right? It's cheating, but whatever. Okay, well, all right, we looked at this one and this one. This is the one that I told you before I move on to that other thing. This is the one that actually counts the number of surrounding cells. We've got our nested loop that looks at all its neighbors, right? It counts the number that are alive and does the wrapping behavior. Now this function's pretty big, isn't it? Let's see, how many lines are we? We're from 15 to 30, so this is a 15-line function. Here I'm kind of stretching the limit in what you want to test in a single function, right? I like to keep my functions, 8 to 10 lines, right? We've sort of maxed out at 15 here. And the question arises, is this too big of a function to test, right, with a single set of specs? I'm going to say in this case, well, usually I keep them small. I'm going to say no, because you saw how simple the tests were, right? Let me remind you. Those were these tests where I was passing in these 3x3 matrices, right? And looking at the result. These are pretty simple tests, aren't they? So even the function is getting on the large side. I feel like if you decomposed it any further, you'd risk sort of muddying it and not being really clear what you're testing it. I think you'd make your job harder to do that. So again, you've got to use a little bit of judgment, right? Anyone who goes too far to the extreme at TDD, is only asking to do extra work that doesn't really help you. So, use your best judgment and don't be too dogmatic about your approach to this kind of stuff. Okay, but moving on, where I was trying to go. I've got this function here that says, is cell alive next period, right? And it calls the functions I just tested. So I call get num surrounding cells alive, and that returns me the number of surrounding cells. I take advantage here, okay. get the actual cell I'm testing, or that I'm trying to determine out of the matrix, right? Right. If I do if one in JavaScript equal to true, right? We all know about JavaScript matching. And then I call either is living cell alive next period or is dead cell alive next period, depending on whether the cell I'm dealing with is alive or dead at the time. It's a pretty simple function, but how on earth am I going to unit test this? Because it calls, at least, I've got calls 3 other functions in here. So if I unit test this, I'm not only testing this function, but the other 2. And that would violate the rules I laid out about what makes a good unit test. So, thankfully Jasmine has a solution for us, and because JavaScript is a dynamically typed language, it's not very complicated. So, here's what I do. I've started a new suite here, first of all, but then on my before each, what I do is use these spies. The spy on is a function that Jasmine gives us, which allows us to test whether or not a function was called. Right? So the engine here, the engine is defined at the top. That was at my very top, little before each, right? So this is a reference to the actual engine I'm instantiating. And then I pass it the function name as a string. And I'm just saying, Jasmine, spy on these, because in my test down here, it determines correctly if cell is alive. Okay? That's what the function does by calling the other 2 functions. All I'm doing is doing this expect with the actual function without the parens, right? Because I'm not calling it. I'm passing a function reference. To have been called. And down here, not to have been called. Okay? Simple. And you can see my input is really simple. It's a 3-dimensional matrix and the coordinates of the cell that I'm passing in. So that's what Jasmine gives us, and I'm assuring in the right case that the function I'm testing is calling the right functions. Notice I'm not actually testing the result of this, that I don't get the result back and see that it returned the correct result. Why don't I do that? I don't care, because those functions have already been tested, right? If I check the result, I'm also checking the results of the other 2 functions I called, right? And I don't need to do that because I know those functions work. Doing that would muddy things up, right? So all I'm testing is that my function calls the correct functions, which is a perfectly valid test. You could argue that this might be a little overkill. Right? I mean, you don't have to go this deep. Again, it depends on your application. You don't need 100% coverage. So just use your judgment.
Now you can put an it inside a describe and a describe inside a describe. Can you put a describe inside an it?
No.
Okay.
What if you accidentally forgot the return, for instance? Like, I mean, a common bug I can imagine, I've totally done it myself probably 100 times, I forgot the return. It seems like the way...
You don't do this?
Yeah, because it seems like your test would then all still pass, but it would be completely wrong.
That's actually a really good point. Okay. Then I would say I would add another spec for like if not null or something like that, or do a type, right? Check the types. That's actually really good. I probably missed a pretty important test that obviously you'd see that when you went to go test your stuff, so you probably wouldn't get too far. But sure, why not? Test the return type, if not the value. Certainly. So now the actual game, right? I split this out into a separate class. So here we're going to run into another problem because the game runner class, which is calls the rules engine class that I just showed you. I was just doing all those tests. That was all for the rules engine class. If game runner calls rules engine, how am I going to test game runner without also testing rules runner or rules engine, right? So the trick there is we borrow something from some of the more strongly typed languages. Is we use dependency injection. So my game runner class, you see how it takes a rules engine in the constructor. At the top of my, right, in the constructor here I've got an instance variable, so rules engine is, so rather than instantiate the rules engine from within the game runner, I'm passing it in. That means in Jasmine I can define the spies on that, right? I have access to it. It's not locked in there where I can't, mock it. Normally in a strongly typed language like Java or C# you would pass a mock in, right? Jasmine makes it a little easier just by using the spies. It's less code and it's a little bit cleaner. So I've got 2 functions here, get next period, right, given the current period. So the current period in this case would be a matrix, and this would return the matrix, for the whole board of what the next, period is. right? These other ones, well, I'll get to those. So when I go to text get next period, right, you can see that it calls the rules engine, right? And this just does the nested loops, right? It loops through the whole damn grid, you know, counting around and figuring out what the next generation should be. So let's look at this. So I set up the rules engine, which I'm injecting into the game runner. Here I instantiate the game runner, and I use constructor injection. Constructor injection, right, means I'm passing it in the constructor. That's a form of dependency injection, you know, if you're curious about the terms, right? And then I set a spy on the rules engine, looking for is cell alive next period, right? And here's my input. It's a 4x4 matrix. Okay, expected input in this one. Expected output. This is what I'm expecting to get back. I fill it out with -1s. You know, or I could put any character in that. My real program is never going to return -1s, right? Because I'm mocking the functions that this function calls, I can make the mocks return -1s, and that way I'm getting a result back based on the mocks, right? Based on what I dependency injection, which is totally different from the actual class that would run when this runs at runtime. Does everyone understand what I mean by that? So, first of all, I'm testing because these. We know that it's a 4x4, so we're going to be calling this, and we know we're going to call it 16 times. So there's another little piece of Jasmine for you, is that you can test whether a function's been called and how many times it's been called. That's pretty cool. The result in this case is the same as expected output because my spy, right, overrode the default behavior and returned -1 every time. So the rules engine I pass in always returns -1 no matter what it's handed off, which is my result is always a matrix full of -1s. So yeah.
I was going to say, I mean, part of the point of that is to isolate specific functionality. So if you haven't written, say, some of the other code that might be behind the production version of that function,
right,
you don't have to worry about that. You can go ahead and write your tests.
I guess you still have to use the spy because you got to, whatever you pass in has to return something.
Oh, right, no, the spy, right, but I meant the actual real function. You can potentially just say, okay, I'm going to delay working that or tackling the bugs that are there and, you know, provide a simpler interface. You could. I usually try to go bottom up, I mean, but you never think of everything ahead of time. So you always end up, you know, mixing and matching and doing it in order. You just do it the best you can, you know, the best you can come up with. So in this way, I've tested what I need to test, right? Because if you think about the requirements of the function, it's that it loops through every square on the board, so we know, and it calls is cell alive next period, right, and returns a matrix with the results. I guess I should have said that first, right? We should have gone through and say, these are our requirements for the functions. It loops through the input matrix, creates a matrix of the same size with whatever the function is cell alive next period returns, right? So this I force is cell alive to return -1, and then I get a 4x4 matrix of -1s. So we know it worked. And I can prove that by running it. That is, oh yeah, correctly determines if the live gets the next period given the current period. Okay, not real descriptive, but we can see the test passed, right? So, am I clear so far? This is like kind of a big point, right? So if there's a place where I should be describing more, explaining more, it's probably this. Does anyone have any sort of questions about where I am now? Cool. So, important questions. We brought up a few of these as I was writing the tests, right? Some of the decisions you have to make when you're doing this. Do we test every method? Well, I actually forgot to show you, but there were a few very simple methods in that game runner class that I didn't test. They're so simple I didn't bother. And that's okay, unless you're writing medical device software or something like that, right? But that is kind of hard, and it depends on some of the, you know, on your team, on how much time you have. And I'm going to talk a bit about that at the end, but do we have to test every method? The answer is no. And it's up to you to identify complexity, the things that could go wrong, but err on the side of safety. Everyone has written functions where it like seems so easy to get it, and then it's wrong, and those are the hardest bugs to track down sometimes, right? So err on more tests better than less, but don't feel obligated to do every one. Do we test private methods? So when you read the Jasmine documentation, or you pick up a Jasmine books, it says don't test private methods, right? You just saw that I did, so I say bullshit to that.
right? But you got to realize this is sort of an algorithmic case, right? These are sort of mathematical algorithmic functions, you know what I mean, which are more prone to errors than typical functions. I would much rather test private methods than test a single public method that calls 4 private methods, right? If you think about like the combinatorics behind that, you saw me write, 20 tests for a single private method and 20 tests for the next private method. You've basically just tested like 400 different cases. If you've got a public method that calls the same 2 ones and you just test the public ones, you'd have to write 400 tests to get the same results, right? 400 instead of 40. So by testing the private methods, you got to get 10 times the output. That's the advantage of decomposing all these things into small functions, is you can test a lot more use cases, right? Just because of the combinations. So, so that's good. When is a class too big? That you look at your test file. If your test suite is like enormous and spans 10 pages, break it down into more classes. It's that simple. And at some points you have to. You saw how I used dependency injection, injecting one class into the constructor of the other in order to isolate functionality, right? You can't do that if you have giant mega classes. If you've got these huge classes with 40 functions in them, keep your classes to 4 or 5 methods max. Right? And that allows you to do this dependency injection and tricks like that and write really testable code. That's one of the keys. When is a function too big? That's up to your judgment. I would say a function too big when when you're trying to test too much with a single set of specs. Your unit test can be a guide for that. If you find, like, to cover all the cases where I'm going to have to write, 100 tests to test this function, it's too big. Break it up into more functions. Okay. How long have I been up here, by the way? When did I start?
About 45 minutes.
About 45 minutes? Okay. Let me wrap it up. I was going to show you equality. Everyone who's dealt with equality knows it sucks in JavaScript, right? You've all seen Douglas Crockford in his famous lecture, and you know that like you can do like 1 equals 1 in quotes, and it evaluates the true, right? Jasmine gives us some awesome stuff like that. Here I'm comparing objects. It doesn't do that natively, right? We know that. Here I'm matching an array which uses, this 2b uses triple equals, and so there's like 2 equal and 2b, and they're different. It's got this like 2b truthy, which is like true, positive integers, objects, 1 in quotes but not 2 in quote, right? So it matches your JavaScript stuff. So, and then the false values, false 0, right? So good stuff there from Jasmine that helps you with the kind of the weirdness of JavaScript, which I know everyone here has dealt with at one time or another. And if you'd written unit tests, it wouldn't have been a problem. It's got very cool asynchronous support, right? So this is a great way to test like the set timeout, so basically I declare this function which just sets value equals 1. Here's the value up here. I start a timer with this func right here, which is calling this one, and after 3 seconds, it calls done, which signals the end of the test. So what this does, basically this is how you can test like functions on a timer. I won't bother you too much by explaining exactly what it's doing, but suffice to say Jasmine has really, really great support for asynchronous kind of stuff, and you can use that to test AJAX calls. I've got an example of that down here. Of course, an AJAX, here I'm actually calling AJAX from a real live server. Now I'm doing something completely different, am I? That's not a unit test, is it? That's an integration test. Integration test is a test that starts at the top of your stack, goes to the database and back, right? Some people mock out the database part, but it's basically testing your whole stack. And that's also very good practice, but the key thing you need to know about that is don't end up in that like middle ground, right? A true unit test is one function. An integration test should be like full stack, and stay out of the middle. Don't be testing like function A calls B, C, D, and E, and you're like testing like a 5-function block, right? That's not an integration test or a unit test. It's like the unholy middle ground, right? So either do full integrations top to bottom or full unit tests. And that also applies to like JavaScript client-side stuff. Now that you've got like cookies and web storage, and I've never used, isn't there like a index database built into browsers in HTML5, right? So those are storage too, right? So if you've got like, you could write an integration test where you start with a click, by triggering a click, does a bunch of business processes, right? And at the end you test to make sure that it's in your web storage, right? that's an integration test because you're testing the full stack front to back, even though it's all browser. But if you do it to the extreme, right? Where you're testing the whole stack and not just some piece in the middle.
A question about the asynchronous testing.
Yeah.
So you were mentioning Jasmine 2.
Yeah.
Is that considered the stable version? When I go to the main site for it, they're talking about 1.3.
Right. So everything I showed you up until that async part is identical. The main changes are that they rewrote the server pieces, the integration pieces in Node, right? It's only that async piece where they basically stole the syntax from Mocha, and I don't know how stable it is. I guess because they didn't attach beta to it, but I couldn't find much documentation. It just came out in December, so Jasmine 2 is pretty new. All right, I was going to get into this, but it sounds like I'm over time, even though this is really, really cool. Oh, it runs CoffeeScript. Very cool. With Node.js, it works with Node.js. It's got like full hooks into your test runner, your test suite, and all that. It's awesome if you're doing that. It's got a Ruby gem that runs when you run Rake, like the same time as your RSpec. It works with Jenkins and Phantom. Phantom's a headless browser, and you can run your unit tests in 6 different browsers at once. It can be like IE7, 8, 9, Chrome, and Firefox, right? And it'll run it using all those engines up on your Jenkins CI server. Awesome stuff. And then I guess, the most important part, TDD gives you fewer bugs. That confidence to refactor is great because you start messing around with code, you're not going to break anything because your tests still pass, right? How many times have you like, okay, I'm going to refactor this. Holy cow, I've got to dig through all my source and see everything that calls that. That takes longer than writing the code itself, right? If you just start writing, you see what tests you break. You know what I mean? So it saves you time. You can actually start coding, actually start refactoring instead of, 2 days worth of preparation before you rewrite your class. You know what I mean? It's repeatable. The documentation is accurate, right? Your comments, your docs, they're never accurate. They're never up to date. This is guaranteed to be accurate when you use that self-documenting feature of Jasmine. It can't possibly break, right? Unless you really messed it up. Frees up your manual testers. It's repeatable. Takes a long time to write the tests, maintaining the tests, waiting for them to run. Can give you a false sense of security. It doesn't save you from manually testing. Sorry to break that to you. And whether or not it's worth it to you, yes, but as I said, strike a balance. 100% coverage is not necessary. Don't ever take like a huge code base and think, oh, I'm going to convert this now and make it unit testable. I promise you, you'll get 5% of the way in. You'll be like, fuck this, it's too much time, right? It never works out that way, right? You have to do it from the beginning, or you might as well rewrite the whole thing. Guaranteed from personal experience. All right? Maintain your tests. Use CI. It's awesome. That's all I got. So, the demo's up on GitHub if you want it. Feel free to hit me up on this or whatever. Questions?
With Jasmine 2.0, the old Jasmine had a facility called WaitsFor.
Yeah.
Did they leave that in place, or did they ditch it in favor of the new system?
They ditched it for Mocha, which is much cleaner.
Well, the reason I ask is because Mocha, I like Mocha, and I've used Mocha a fair bit. It doesn't always do a great job when you have nested asynchronous tests.
Yeah.
And something fails somewhere in the middle, or even at the very end.
Yeah.
Bubbling those exceptions up, it can sometimes you can get erroneous answers back
from
the test. Yeah. And I'm wondering if the Jasmine folks maybe did a better job.
I don't know.
Okay.
I haven't gotten so deep that I've come across anything like that. That's not to say I probably haven't given it something that tricky.
Okay.
So
sure.
Yeah. Yes.
Are these slides available?
Yes. I will post. It's on Google Docs, and I'll post it on the Meetup. Cool.
So talk about a couple of little things that you didn't mention that people
Yeah.
might find useful, and that is that if you wanted to comment out one of your specs just temporarily, you can change it to itx.
Exit. Yeah.
Exit.
Yeah.
And you could do the x describe as well.
Yeah, so instead of commenting come out, that's kind of cool. Yeah, you put the little x before it or x, so there's a function xit, xdescribe, and it won't run them.
And I've run into some cases where if I reach this point in the code, it means something went wrong and I want my test to fail, and there's a fail that you can call. In addition to assert something, you can just say fail.
You reach this point in the code, so you're not doing the whole test? You're not completing the test?
So if you have a complicated if statement, and it's like if this whole condition is true, then you want to just fail, right?
I've not come across that.
Yeah.
So
Yeah, and then one thing that...
if you use the spy though, if you use the spy, well, no, because the spy can only map a function. I didn't see that. Okay.
So one thing that different test frameworks have a different opinion about is what should happen if you're in a test and you have multiple asserts, and let's say the first one fails, what should happen? Many of them will bail out of the test at that point. Some of them keep going and run all the asserts, and that's the way Jasmine is.
Yeah.
And the thing that I kind of don't like about that is that my first assert might be this object is not null.
Right.
And then it is null, so that assert fails, and then the next thing I'm going to do is call some method on that.
Yeah.
And I didn't want it to keep going.
Well, see, in that case, I would split that up into 2 different tests, right? I mean, a single spec, right? Single test just for the null condition is probably the better way to do it.
So, but it's still going to run that other spec.
Well, then you'll have 2 error messages. I don't know. Yeah.
Do you have a lot of experience with testing things that where you have issues with race conditions, potentially, if you're going to have bugs? Because that's the stuff I've always struggled with, figuring out how the heck to test it.
In a multi-threaded environment?
Well, a multi-thread or a distributed environment, things like that, you know?
Yeah, that would be like the subject of an entire another thing.
Do you have any resources or thoughts on that at high level?
No, sorry.
Okay. I know some of the assertion libraries like Chai and some of these others are trying to do more interesting things with regard to introducing concepts like when, you know, and then having combinators with those as well, so that you can combine asynchronous logic with, you know, all this stuff happened as like kind of a gate to where you would go on to the next part of the test or something like that. I mean, you know, in other words, trying to limit the impact of the race conditions. But I don't know if that's exactly.
Any more?
How do you find Jasmine's spy facilities? I mean, compared to something like Synon? Like a library like Synon's got, you know, it's been around a long time, and it's got a huge number of.
Well, for me, like I don't know Synon. I never used it. For me, it's like a dream come true because I came from C# and being strongly typed, like the mocking, you're forced to use dependency injection for every single class. You can't just like. For me, this is all just like icing. It's like, wow, this is so much easier. So if there's something easier than that, you know, I would be probably pleasantly amazed. I'm so happy with this that I guess I haven't asked for much more. But yeah, I don't know. I think Synon, is that the one they use when you write? Is that the one you use when you write Mocha?
Yeah, or it's an option. There's some other spy libraries out there. Just Synon's been around a long time, and it's got an enormous number of bells and whistles. So
yeah, I wouldn't
use
know.
it with Jasmine.
You could. I mean, there wouldn't be anything to prevent you from using it with Jasmine.
Yeah. Oh, was that him? Oh no. Who else?
How's that spelled?
Sinon. Have you used the Karma test runner at all in combination with Jasmine? I know there's a plugin for the Karma test runner.
I haven't. I've only used it in Rails.
Okay.
I have been.
How do you find that one?
It works fine. Karma is supposed to support Mocha and QUnit as well, but I find that the Angular team, because they prefer Jasmine, they've made sure that works better than the others.
Yeah, I mean the commit history on that plugin seems far and away much more active than the other two. Anybody got any more questions for Brad? All right, Brad, well, thank you very much.